yeah, so I think Herman should be joining us, right, for today.
I'm not sure. He
Oh,
didn't.
did he send a message?
He didn't. No, he didn't. Let me just check again.
Okay, okay,
No, he didn't. He didn't.
okay, okay. All right. So
Mhm.
maybe you can ask. Okay. All right, but I think we can start. Okay.
All right.
So yeah, so you like to maybe update us about what's the current state and
All.
any the updates? Okay.
Yes. Yes. So I'm just gonna share my screen.
Okay.
Sorry, let's ignore that. So just want to sort of show you like a preview of what it looks like. Yes.
Okay.
Well, I'm running the stuff now, but so yesterday I was on campus with Professor Herman,
Okay.
and he actually made some changes as well to the
Mm-hmm.
existing code, such that the the simulator can allow for both simulation and real networks.
Oh, nice. So
Yeah,
he
it's
did the
almost like
change already?
he
He
did
did the
everything. I was like, what? And it's taking like an hour. Like
Well,
dude,
again, there's a reason why he's called the
respect.
professor.
Yes, respect, respect.
Yes. Okay. Yeah.
uh, but it's sort of so he showed me sort of how to just run the code. So if you
Okay.
notice,
Nice.
I
Nice. But
just
I'm
like
pretty sure you've learned a few things along the way, right?
yes, yes.
Yeah.
This
Yeah.
is
Yeah.
quite
Okay.
interesting, and I
Yeah.
sort of like the way he added um the vast interface
Okay. I
like
see. I
from
see.
the beginning. So
Right.
when
Right.
it's not going to be too difficult to integrate with
hmm
the existing
I
vast.
see. Yes. Right.
Anyways, so if you look at basically when you look at this, let me just so there's a matcher. So this is like a
Right.
standalone matcher now.
Right. Right.
It's not its own matcher with
Okay.
this, So the idea is I'm creating this with this IP and this port, and then I'm
Right.
starting the matcher,
Okay.
and now I'm creating nodes,
Right.
right? Standalone nodes to connect to this matcher,
hmm
but at different ports now and different
Right.
IPs.
Okay.
Here it goes into a bit more specifics where I'm saying now in this node I want you to publish,
Uh-huh.
and then so what am I saying? Sorry, I want you to channel, and you so this is the channel it's on, and
Okay.
this is a subscription request.
Okay. I see.
So
Okay.
this is the node channel test, and I want you to subscribe to channel 2. And
Okay.
the idea is this is the matcher.
hmm
Basically, as we generate new nodes, it's
Right.
receive it's receiving some of these things. And I think at the moment, the key challenge now, especially from a simulation perspective, is going to be
hmm
let me just look for this file. Um, where is it now? Oh, sorry, I've not opened it yet. It's basically going to be uh generating those nodes, like sort of having like a gateway matcher that has an
hmm
idea of
Okay.
where the nodes are. Let me just open this. Mm, Jeez. Jeez. What's going on now? Sorry. I'm trying to open file instead of folder.
hmm
Okay. Sorry. Just 1 second. Come on. Okay. So if I open single matcher, oh sorry, the single matcher, yeah.
Right.
If you notice, the stuff is sort of generated here, for example.
Okay.
So there has to be some sort of way in the simulation, like, and that's where the gateway might sort of play a role,
hmm
because now the join is sort of hard coded and it's not necessarily
Right.
typed. Yeah. So this will work on that. I will work on that to find the dynamic way in the larger network of things. But the system works, I think. I mean, from what I noticed, if you noticed here, I tried to play around with the nodes. So I created channel, for example, there's test and then there's channel 2.
Okay.
I created different channels to sort of play around with it. Geez, sorry, I forgot to simulate the area version as well. But the area version works, it sort of runs similarly. The only
Okay.
difference is I sort of pass in the parameters, which is the position, the X, Y, and then the R. And
Okay.
basically, if there's an overlap, sort of the same process occurs. And I think the key next step, and I'm just gonna show you this. I'm sorry. So I'm trying to sort of plot this out in terms of what I want the simulation to be like. I don't know if you can see this properly,
Okay. Okay. Right.
right? So these lines are supposed to simulate some sort of Voronoi partitioning,
Okay. Okay. Sure.
right? And if you look at here, I tried to manually generate the nodes one by one. So this is the first test case now, where you have a matcher area, right? And I'm gonna ask a question after this, but you have a matcher area, and then you have all these nodes in that area, node 0, node 1, and in the simulation part, or should I say in the implementation and testing, I plan to first manually do this, like generate all these individual nodes with some just publishers, some just subscribers, some having both publishing and subscribing functionality, right?
Okay.
And that's node
Right.
2 here. And the
Okay.
idea is, in theory, this matcher is connected to matcher 1 is connected to matcher
Right.
2, or at
Right.
least it
The
knows
neighboring
about matcher 2.
matches. Right.
Yeah, the neighboring matches, and matcher 2 knows about what matcher 3 is. Let me, so I'm gonna just put that so I can see that. All right. And the idea is, in theory, if I subscribe to, let's say, channel 5, let me call this 5,
Right.
right? There should be a way for this to get the information from that matcher.
Right.
So
Exactly. Right.
yeah. And so I want to test this for exactly 4 nodes on each matcher. So at the moment, this is like 4 different matches with 4 different nodes. And so there's going to be testing for this. There's going to be a result analysis for this as well, as to what's the latency and what's the scalability, and how fast does this happen, that kind of stuff. And then
Okay.
once it works perfectly, or at least it's doing what we expect it to do, of course those results will go into the paper as well. And then we will now do some sort of generator to automatically sort of generate these nodes for like 1,000. So let's say 100 here, 100 here, maybe 500 there, with random channels, so, generated random nodes, random channels, and random
Right.
areas, and sort of. But my key question sort of comes in as to, in terms of the matcher, right? The matcher area, is this defined by like a region like this, or is the Voronoi region the matcher, or is it the combination of both? I don't know if you
Okay.
get
Okay.
the
All right.
question.
Yes. Okay. All right. So, all right. So, okay. To answer directly,
Yeah,
okay. If you are using Voronoi to do the partitioning,
yeah,
then the matcher region should be the Voronoi region,
okay,
okay,
okay.
instead of a rectangular shape
Instead
region.
of, okay,
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 that's the to answer your question directly. Okay,
that makes sense.
okay,
Makes sense. Okay, okay.
and
And
and okay, and I guess any other updates or thoughts on your
sorry,
side?
just to follow up on that. So the vast library already does the partitioning. Just to confirm.
Yes, that's
The
the most basic BOM, which is the
mm,
Voronoi overlay network. It does the partitioning, it does the node discovery, and also allows you to connect to your neighbor enclosing neighbors.
okay.
I think those are all done for the JavaScript version, and
Okay.
also obviously the original C++ version.
All right. All right. Thanks.
Yeah, but
Okay,
there's not
that's
yet
fine.
a Python version. So yeah.
Okay. Oh,
Um,
okay, I see what you mean.
okay, so
That's
any
cool.
other
Okay.
questions?
Yeah, no, that's fine for now. I'm just so one of the things I've done now is I reached out to another friend of mine
Mhm.
who I know is a software developer as well,
Okay, okay,
who has also had extensive um what do you call it, background in stuff like Docker, for example.
okay, okay.
And the idea is hoping that we can all work on it over the weekend.
Mhm.
Um,
Okay,
and is you and him.
okay,
Obviously, I'll probably not spend a lot of time on it, but the idea is we'll probably like look at the code at first and see how it
okay,
works, see how
okay.
we can deploy it for like individual nodes. And I think I'm forgetting something.
That's good.
Uh, in the meantime, with
The paper part, the writing.
yes. So the writing,
Mhm.
okay. So there's I've done some, but not a lot. I was trying to sort of design this, but let me see.
Okay.
Let me just try to open it. Where is it? Just give me a moment. Ah, come on. Sorry, there was quite a lot of load shedding as well. Well, like
Mhm.
electricity basically goes off nowadays. We went had like stage 4 yesterday.
Mhm.
I hope it's this. Ah, yeah, so at the moment it's still basically like the theoretical approach to things. Is this it?
Mhm.
Yeah, that's the one. I have some new what do you call it? Sort of written somewhere else. I have to find that. But I have some more like background research done as well. I
Mhm.
wrote that somewhere. I don't really know where. I have to look for that. But everything is sort of under control at least for this week. I think I
Okay.
just need to integrate what I've written here. Sorry about that. I thought
Mhm.
I already put it here. But to sort of integrate, the background research I've done and to clean up this section, which is
Mhm.
what we want to do in terms of
Right.
comparing the existing PubSub and the current PubSub. And I think the key part will now be the approach we are trying to take, which is
Mhm.
where all of these information sort of comes in,
Okay.
which is the design, the structure. Well, this is probably gonna look cleaner than this, but this is just supposed to be a general idea of what the system should look like and how
Mhm.
the nodes sort of access or create make requests, or how the matching sort of occurs. That makes
Mhm.
sense. Yeah.
Okay. Okay. All right. Okay. So that's the current update, right?
Yes.
All
Yes.
right. Okay. So okay. I have a couple of feedbacks.
Okay.
One is related to the simulation. Okay.
Okay.
I think the point of the okay. So obviously there are two things we can test on. One is channel-based PubSub.
Yeah.
Okay, and the other is the spatial base.
Yeah.
I think right now the important thing is simply um, to use a single matcher.
Okay.
Okay, just a single matcher. And I
Okay.
mean, in the testing part, just a single matcher, and then just see its scaling, sort of observing and recording its scaling behavior. Meaning that as the number of nodes increase, and as they're doing these pops up maybe randomly, like what is like the loading of, in terms, let's say the bandwidth use, right? The message
Mm.
send and receive at the matchers, and also at the at each nodes, right? And if
Yeah.
you can also record perhaps some latency, that will also be helpful. But
Okay.
essentially, you want to plot a graph. And okay, so this is something I encourage you to do actually, regarding
Okay.
the experiment. is to
Okay.
draw what you expect to see, the final results diagram first.
Okay.
Right? Remember I told you about, you can
Yes.
sort of draw what you are expecting, right?
Okay.
And just sort of like a mock-up, right? And you
Okay.
can even put that in the paper first, right? To
Okay.
explain, and then run the experiment to see if it conforms to sort of your hypothesis or your
Okay.
hypothesized results, right? And
Okay.
what we should what we should expect is that the resource usage in terms of either bandwidth or maybe in terms of like latency, the performance, it should
Yeah.
somehow increase, right? Linearly or even super linearly along with the number of nodes.
Yeah.
I mean, this is understandable, right? I mean,
Yes. Yes.
yeah,
Absolutely.
yeah. So super linearly means that it can even go faster than linear. So that means as the number of nodes that gets beyond a certain point, the performance drastically reduced. Okay,
Okay.
becomes much worse, right? This is what we should expect from just a single matcher or a centralized system. Okay.
Okay.
I think at this stage for our submission, I think that is enough. Okay.
Okay.
Just to say that we have a working implementation of channel and spatial-based POP-SOC, and we can already show that it's not scalable. Even though the functionalities are there, let's say the channel or spatial POP-SOC works correctly, right? But
Yeah.
the performance or the scalability does not seem to be sustainable. Okay. I think that's the only thing. The only thing we should do now for the experiment, given the 3 weeks that's left. So don't worry about multiple matchers, anything like that. I don't think, because one, it's not in the implementation yet, and second, we probably need to design first in terms of also the protocol and message. Okay.
Yeah. Yeah.
How do you support a decentralized version of basically the matching, the matching part, right? The mattress function. Essentially, what we want to do is to decentralize the mattress functionality, right?
Yep. Yep. Precisely.
Okay. So Victor, is that all right? I mean, so
It makes sense.
don't worry about, right? And
Multiple
regarding
matches.
the paper part, yeah, but that's the important regarding the paper writing or we have to come up with the design. Okay. Both in terms of conceptual design and also the step-by-step procedure, protocol messages. That should be laid out, I think, in this work.
Okay.
And that's like one of the main contributions of the paper or the doctoral symposium. Okay.
Yeah. Makes sense.
Okay. So with that said, regarding your diagram now, I do have a quick feedback is okay. I see you have both. It looks like this is a diagram for channel-based POP-SOC functions, right? But using multiple matchers to actually try to sort of distribute the load. Is that what it's intended to do?
It's actually supposed to be a bit of both, but I think I forgot to add the
my
position.
feedback is don't mix the two. Okay.
Okay.
Do say spatial and channel-based separately, if possible. Okay, because then it will be too confusing in terms of if you want to. Okay, let me put it this way. I believe we can use the same underlying partitioning mechanism, which is obviously some kind of a spatial-based partitioning to support both channel-based and spatial POP-SOC. Okay, it's entirely doable. Okay, And, because you can imagine, right, right now for channel base, most of the partitioning are probably involving some kind of tree structure, right?
Mm.
That's a, quad tree or different binary tree, whatever kind of tree. And they use that to quickly sort out and, decide how you want to look for, index a particular channel name, basically, okay?
Yeah.
But you can, exactly like what you draw here, you can also imagine that the thing can be spatially partitioned. You see?
Okay. Yeah.
Okay. But the way to do this, however, is that you want to sort of again have a way to map channel name onto the space somehow. Okay.
Yeah.
And then basically make a division of the space. You see?
Okay.
Okay.
I'm trying
So
to.
so this is, I mean, this
Oh,
is
okay.
okay. So
Oh,
this is something. I mean, actually, okay. I think there are two ways to do this, but I think this is getting ahead of us
okay.
because I like to emphasize. I think the core of our work should be about how to support spatial PubSub using spatial partitioning.
Mm.
Is that all right? Okay.
Yeah.
However, it's also possible actually to support channel-based PubSub using spatial partitioning.
Okay.
You see?
Mm.
Okay, it's possible because exactly like what you have drawn here. Okay.
Yeah.
I think what you have drawn is that there are different interests, right? There are different interests for different nodes. So, I mean, there are two ways to doing this. One is, for example, each node, when it joins, it just joins at a random location, spatially, okay?
Yeah.
And we also allow that node to subscribe or publish anything. Okay,
Okay.
you see?
Yeah.
And the way that you make sure that the publication or subscription can match up is that you will sort of do a broadcast, to the whole space for
Okay.
any subscription or any publication.
Yeah.
Okay,
I see
but
what you mean.
you see, but that may not be too scalable. It's doable, but it may not be scalable. Okay, because you can
Yeah.
imagine if any message, any publication subscription has to be sort of spread through the entire space by forwarding, right?
Yeah.
This is essentially an out-to-out communication. Okay, so it would not be scalable. Okay,
Mm.
but you can, what you can do, however, is all right. I guess I'm again getting. I mean,
I
what you can
no, it's good to know
do
now.
is,
To
yeah,
think of it. Yeah.
right. I mean, but you have to understand. Keep this in the back of your mind to understand that this is
Yeah.
doable and feasible. What
Yeah.
you can do, however, is let's say you have a. Sorry, let me put it this way. I think what's more feasible is that every time you have some kind of a subscription request, okay,
Yeah.
again, you sort of send that. Okay, one potential way to do this is to divide the space. I mean, basically divide the channel names into, different space and have a way to map the channel name to, again, sort of the nearest matcher, okay, that sort of manages that namespace, okay? And you can have different ways to do this. For example, you can simply, again, have a forwarding model, okay, that just, you can start from one matcher and it forwards to its neighbor in a certain direction.
Okay. Yeah.
Until
Yeah.
it finds, okay, a matcher that manage the namespace. You can even adjust the spatial regions, to do some kind of load balancing, you see. But I
Yeah.
guess what I'm trying to say is, in the end, what happens is you will have the entire space be divided by the number of matchers available. And every
Okay.
one of the matcher manages a definite set of namespace for the channel name. You see
Okay.
that?
Makes
I
sense.
mean,
Yeah.
is it understandable so far, Victor?
Yeah. Yeah. It is. It is.
Okay, so what happens is all these subscription requests, you will have to find the right matcher. Okay, regardless of where it's generated from any node, that's fine. Okay, but it will be forwarded to the right matcher and be registered there. You see, the matcher
Yeah.
becomes sort of like a register for the requests. And similarly, for publication requests, all the publications will get forwarded to the right matcher that is managing the namespace. Okay, that that matches the published channel. You see, and then you can find a list of the subscribers at that matcher and then just forward it to all the nodes that's on the list.
Okay.
Okay, so that way you can support channel-based PubSub, but using a sort of a spatial partitioning approach.
Okay.
Is
So
that clear?
yeah. So it is something possible.
Yes, it is possible. It's possible, and I wonder, and I suspect some people might have already proposed that, although I'm not sure because I haven't seen any work like that. Okay, but it is theoretically possible to do that. Okay.
Yeah.
Now, the interesting thing is why do we want to go through all the length of doing this? Okay, is because obviously a spatial partitioning is perfectly suitable for spatial PubSub. See?
Okay.
So in other words, you can potentially design an architecture that based on spatial partitioning can support both spatial PubSub and also channel-based PubSub at the same time. Okay, and I think that is powerful in its own right.
Yeah. Yeah.
But does that make sense?
Yeah. Yeah.
Okay.
Okay.
I'd like to make sure that you get what was just being sort of discussed. Is that
Yes.
okay? Okay, you're
Yeah. No,
clear.
that's fine.
Okay.
Yes.
Okay.
Yes.
All right. All right. However, that being said, I don't think that's the current focus. Okay.
Yeah. No. No. It's not the current.
You see,
But it is.
because
It is quite.
yeah. But
Yeah.
this is obviously, I mean, the current work we can, at some point we can do and mention that part, even maybe work on that. But right now, I think the priority is obviously channel-based PubSub solutions. But in terms of spatial PubSub, there's probably a lot less.
Okay.
Okay.
Makes sense. It makes sense.
All right. So for spatial PubSub, the diagram you cannot draw like this. For each node, you probably will have to draw like different size of different subscription or publication areas. I mean, for the different sizes, radius, and then the matcher in the background. Okay, that would be more understandable.
Okay. Okay.
Okay. Or I don't know. Or it's also fine if you have the same radius. We can mimic that. It's like taxi or persons walking on a plane on some space. But then make sure that the nodes are spread out. Instead of like all cluster in the center. You see, because that is not the partitioning of the matcher should be transparent to the actual nodes that are, just think of the actual taxis. They could cluster, but probably not in this way, right?
Yeah. Yeah.
Right? Do you see what I'm saying?
I see the picture. Yeah.
Yeah, and you even need to draw some circles that are that's kind of at the boundary of matchers, that its subscription or publication area is sort of overlapping two matchers
the
or even three
area.
matchers, right? You see, I guess what I'm trying to say is you need to present that kind of idea, that visual sense of nodes moving, or nodes on a space, but then there's underlying natural partitioning.
Okay.
Okay.
Oh, yeah, makes sense. Makes sense. It's an interesting. We'll definitely get to that. I'm pretty sure we're gonna.
Okay,
I'm pretty
okay.
sure we're gonna
I
get.
mean, you can include that in your current draft, actually, because it's just an idea, right? It's a thought that we will explore in the future as well, right? Although maybe not as critical as figuring a way to support spatial pop-up folding.
True.
Okay.
I agree. I agree.
Mhm.
I agree.
Okay,
All
all right. So for tomorrow, I think if you can obviously adjust the figure, okay, to better match that, that's the first item, okay, to basically show just spatial pops up, okay, and no channel base,
Okay.
okay. I mean
Yeah,
that's one.
that's the plan.
And the second thing, I guess, if you still have the capacity, is try to create the first design draft, okay, or the mechanism. You can bullet point the ideas. That's fine too. But how
Okay.
are we going to, decentralize the matcher function using something like ROM?
Okay.
Right.
Yeah.
And you might want to describe how this works, or maybe you could list them the steps, the procedures
Okay.
of how this happens, right?
Yeah.
Okay.
Yeah. Okay.
Okay. And I think I'd like to get to the let's try to get the design done next week. Okay. And
Yeah.
then
No.
the protocol part, the message protocol and message format done the second week. Okay, that's
Oh
do
yeah.
that. And the third week should be some kind of integration and proofreading.
Okay.
Okay.
That
So
makes
would that be
sense.
all right?
That makes sense. Yes. Yes.
Okay.
That makes
All
sense.
right. Okay. All right. So any other questions from Victor?
Uh, that's it for now. That's it for now. Thank you.
Okay. Okay. Great. All right. Okay. So yeah, and outsource the coding part and I mean the experimenting part for now. Okay.
Yeah. All right.
You should start to focus on the paper now, and just providing, I guess, instruction and feedback for the experiment. Okay.
Okay.
All right.
I'll do that.
Okay. Okay. All right. So good luck and take care, and we'll see you tomorrow. Okay.
Thank you.
Okay.
Tomorrow on Monday.
Sorry. Monday. Sorry.
Just to be sure.
I'm
James
blind.
was a
Oh yeah. So yeah. Sorry. Herman
mastermind
is
is
not
next
joining.
week.
Sorry, Herman.
Yeah.
I forgot it's Thursday already. Okay.
Yeah, time is flying for some reason this week.
Yeah. Okay. All right. But we made a lot of progress as well. Okay. Don't
Yes,
overlook
yes,
that.
that was great
That's good.
progress. Well, thanks so much.
Okay.
Thanks.
Okay. All right. So take care. All right. So
You
good luck
too.
and have a great
Cheers.
weekend. Okay.
You too.
All right.
Bye.
Bye-bye. Yeah, bye.